Exercise 4.4. This is called brief truth tables, or partial truth tables sometimes. This is a way of doing truth tables that saves you from writing out the whole damn truth table. And if you did any of those, 16-line truth tables from the Q2 problems, you know that writing out whole truth tables can be a pain in the butt. So if you master the partial truth table method, you can save yourself a lot of time and effort. All right. Now you can use partial truth tables for really anything you use truth tables for, but it's going to be slightly different depending on if you're doing equivalence or consistency. In 4.4, we're using brief truth tables to determine whether an argument is valid or not. And if you did exercise 4.3, you know, and especially if you watch the video I made for it, you know that the way to prove an argument is invalid is to show that there's a line on the truth table where all the premises come out true and the conclusion comes out false, right? So if we look at number 2 here, the basic idea is there a line on the truth table where the premises will all come out true? There's only 2 premises here, and the conclusion would come out as false. Center these so they maybe line up, right? Because that's the only line on the truth table we care about. If you remember the very last problem in exercise 4.3 that I did, and I'll go back and show it to you real quick in case you didn't watch that video. This is number 10 of 4.3. We went through every single line in the truth table, and it was the very last line where we finally found a line where all the premises came out true and the conclusion came out false. So in other words, we wrote, this is an 8-line truth table, so those first 7 lines we wrote were completely wasted. All we really needed to find was this 8th line. And partial truth tables or brief truth tables give you a way of saving yourself all that time, right? And here's how, right? We want to find a line where the premises are all true and the conclusion is false. Again, I'm using the backslash to separate the conclusion from the premises. Now, the only line where the conclusion is going to come out false is, of course, lines where P is false. In other words, if we were looking at a whole truth table, the only lines we have to bother looking at are lines where P is false, because on lines where P is true, the conclusion is going to be true. And that's not going to be a line where the premises are all true and the conclusion is false. Right? So that's the key to partial truth tables is, remember, you're looking for a line on the truth table where the premises are all true and the conclusion is false. If you find it, then the argument is invalid, right? If you don't find it, then the argument is valid. So if we want a line where the premises are all true and the conclusion is false, the only lines where that's going to be possible is the lines where P is false, because otherwise the conclusion will come out true. So we know we only need to look at lines where P has the value of false. Right? So if P has the value false in the conclusion, it also has the value false here. Right? And if a conditional has a false antecedent, then it's going to be true, right? So by making P false, we've made the conclusion come out false, and we've made the first premise come out true. Now, if P is false, that means it's going to be false here as well. And if we have a conditional that has a false consequent, the only way to make it come out true is if the antecedent is also false. Because if this antecedent were true, then you'd have true antecedent, false consequent, and it would be false. But remember, we're trying to find a line where the premises are all true and the conclusion is false. And indeed, we have found it. So if P is false and S is false, First premise will come out true because P is false and it's the antecedent of the conditional, so the conditional is true. We have false, false here, which makes the conditional come out true, and we have a false conclusion. So if P is false and S is false, the premises are all true and the conclusion is false. And so that tells you that it is an invalid argument, right? Because you did find a line where the premises are all true and the conclusion is false. So the idea then is, again, that's what you're looking for in the case of valid, invalid. You're looking for a line where the premises would all come out true. So this is number 4 now. So we want a line where the premises would be true and the conclusion would be false. Now, what helps in these cases is because, like in number 2, there's only one way to make that conclusion come out false, namely if P is false. Again, if we look at this conclusion, it's a disjunction. And there's only one way to make a disjunction false. That's if both disjuncts are false. So B has to be false. So we set B to false here. And not A has to be false, right? Because we want false, disjunction, false. For not A to be false, though, we know that A would have to be true. So the only way to make the conclusion come out false is if B is false and if not A is false, which means A has to be true. So the values of true for A and false for B gives us a false conclusion. We also need a true premise. There's only one premise in this argument, right? So if B is false, not B comes out as true. Right? And if A is true, not A comes out as false. But now you can see we're in a bit of trouble here, right? Because we need the premise to come out true and the conclusion to come out false to prove that it's invalid. But the only way to make the conclusion false is with these values. A is true, B is false. But those same values guarantee that the premise is going to come out as false too. So we need the premise to be true to prove invalidity, but the only way to make the conclusion false makes the premise also false. So what that tells you is there's no possible way to make the premise come out true and the conclusion come out false, and that tells you it is a valid argument. All right, 2 is invalid because we did find values that make the premises all come out true and the conclusion come out false. But here, that's impossible. Why? Because the values that make the conclusion come out false also make the premise come out false. So there's no way for the premise to be true and the conclusion to be false. That tells us it's a valid argument. All right, number 6, we've got 3 atomic sentences. So again, this would be an 8-line truth table. So we're saving a lot of time and effort. We're looking for values that would make the premises all true. So we want this to come out true, this to come out true, this to come out true, this to come out false, right? If we can find values that make the premises all true and the conclusion false, we prove it's invalid. If we can't find those values, if those values turn out to be impossible, then it's valid. So start where it's easy. There's only one way to make X come out true, and that's if X is true. There's only way to make not Y come out true, and that's if Y is false. Right? So if we choose the value true for X and false for Y, we get these 2 premises true. The only way to make not Z false is if Z is true. Right? So making Z true gives us a false conclusion. So now we just got to go back to this first premise and see what happens when we plug these values in. So X and Y is a conjunction, but if one of them is false, the whole thing comes out false, right? And now we have a false antecedent, and that indeed, if the antecedent of a conditional is false, the whole conditional comes out as true. So if X is true, and Y is false, and Z is true, we get true premise, true premise, true premise, false conclusion, and that means it is an invalid argument because, remember, a valid argument, there's no way the premises can all be true and the conclusion could be false. So if you find values that make the premises all true and the conclusion false, you've proven it's invalid. All right, number 8, again, we've got 3 atomic sentences. This would be an 8-line truth table. We've got 2 premises, P or Q, conditional P or S, and then just P by itself, and the conclusion is just S, right? And again, we're looking for a line that would make, or we're looking for values, sorry, that would make the premises come out true and the conclusion come out false. The only way S comes out false is if S is false. The only way P comes out true is if P is true. So by setting those values, we get 2/3 of what we need. We get 1 true premise and a false conclusion. So now what's left is this. So if we have P is true, right, and never gonna get those line up, and S is false, right, this is going to come out true. Doesn't really matter what Q is, right? Because as long as P is true, this disjunction is going to come out true. So we have true antecedent, true consequent, which does indeed give us a true conditional. And so that premise is true. And again, we've proven that the argument is invalid. Now notice Q, it didn't even matter, right? So sometimes you'll see this written like that to show that Q could be either true or false, doesn't matter. And what this tells you is that if you wrote out the whole truth table, there'd be at least 2 lines where you get all true premises and a false conclusion. One of those lines would be P true, Q true, S false. The other line would be P true, Q false, S false, right? So it doesn't matter if Q is true or false. As long as P is true and S is false, we get true premises and a false conclusion. And all you need is 1 line. So you could either just randomly put whichever value in there, right? Because all you need to show invalidity is 1 line where the premises are all true and the conclusion is false. Or if you want to show that it doesn't matter, you can do the backslash like that. Either way, you'd get full credit for that solution. All right, number 10. Again, we've got 3 atomic sentences. This would be an 8-line truth table. We want values for H, I, and B that make the premises come out true and the conclusion come out false. There's only one way to make a disjunction false, right? That's if both disjuncts are false. So I and B both have to be false in order to make this come out false. There's only one way to make not H come out true, and that is if H is false. So if H is false, then not H is going to come out as true. All right, so now we've got to figure out if these values will make both these premises true. All right, so B conditional H is going to be false, false. So that's going to be true. And I is false, right? So that means we're going to have a conditional where the antecedent is true and the consequent is false, and that is not going to be a true sentence. It's going to be false. So we can see from here right now that we've got this contradiction. We need this to be true to show it's invalid, but to make this premise true and this conclusion false, the values make this premise also come out false. So again, what that tells you is there's no possible way to make all the premises true and the conclusion false. And so that tells you it's a valid argument. And again, you know that now without even having to bother with this, right? But here you'd have the same basic thing, right? H conditional I would give you a true antecedent. B is false, so you'd get true then false, and this also would be false. So there's no possible way to make the premises all true and the conclusion false, so it is a valid argument. All right, number 12 is a four atomic sentences. So that would be 2 times 2 times 2 times 2, 16-line truth table. So you're saving lots of time this way. Again, what we're looking for is values that would make the premises all come out true and the conclusion come out false. And again, you can really start anywhere, but you want to start somewhere where there's only one possible way to make it true or false. So like for example here, this is a disjunction. There's 3 ways to make a disjunction come out true. They could both be true. This one could be true, this one could be false, this one could be false, and this one could be true. So there's lots of possible ways to make a disjunction come out true, so we don't want to start there. There's 2 ways to make a biconditional come out true, so we don't want to start there. For this one to come out true, what's inside the parentheses has to be false. But again, there's multiple ways to make a conjunction come out false. Now for this one though, in order for the whole thing to be false, what's inside has to be true. Right? And there is only one way to make a conjunction come out true. That is namely if both conjuncts are true. So if D is true and K is true, then we get true inside the parentheses, but we negate it and we get a false conclusion. And that's the only way to make the conclusion come out false, right? Only if D and K are both true does the whole sentence come out false. So that's why we start there, because it's a situation where there's only one possible set of values that could make the conclusion false. And now that we know that, say, D is true, and we put true in there, then this disjunction is going to come out true, because for a disjunction to be true, it only needs one disjunct to be true. Here, for not D, so if D is true, not D is going to come out false. And that means we need K to come out as false, right? But we've already established that K has to be true in order for the conclusion to be true. Sorry, for the conclusion to be false. So again, we get this kind of contradiction. Right? We need the premise to come out as true, but the values that we need to make it true would also make the conclusion come out true. So again, what that tells us is there are no lines on the truth table where the premises all come out true and the conclusion comes out false, and that means it is a valid argument. Okay, and the very last one, number 14, again, it's a 4 atomic sentences. So that means it would be a 16-line truth table. We want to see if we can find values that make the premises all come out true, conclusion come out false. So again, we want to try to start where there's only one possible way. Just double checking to make sure I wrote the problem down correct. There's multiple ways to make a disjunction true, multiple ways to make a disjunction true, multiple ways to make a conditional true, right? For this to be false, what's inside the parentheses has to be true, right? But again, there's multiple ways to make a disjunction come out true. So what do we do in this case? Well, in such a case where there's no clear place to start, you have to just sort of plug some values in and see if they work, right? So if we make U false and we make B false, And let's make B true. All right. So we make B true and U false. Then we get true or false, which is true inside. And then the negation of that will be false. And again, the reason I picked those values, it wasn't just random, because if U is false here, then this conditional has a false antecedent, and so the whole conditional is going to come out as true. So making U false gives us this premise come out true, and making B true is going to make this premise come out as true as well, since if the consequent of a conditional is true, then the whole conditional is going to be true. All right, so let's see. Now, though, yeah, that works here too, because we get if B is true, not B is false. But if U is false, not U is true. So that those values give us this premise as true as well, right? And so you can see we're in pretty good shape if we're looking for values that make everything true, premises true, and the conclusion false. So far we've got B and U as T and F, right? So T disjunction F gives us T, negate it, you get F. If U is false, the antecedent here is false and the conditional is true. If B is true, the consequent is true and the conditional is true. And if B is true and U is false, we get a true here. So all that's left to do is to make this premise come out true. And there's, again, plenty of ways, but we could make this true and this true, right? And that'll give us true premise, right? So these values, and they're not the only values, because we could have made M true and Z false, or we could have made M false and Z true, right? So there's probably a number of lines on this full truth table that would prove this is an invalid argument, because there are values that make the premises all come out true and the conclusion come out false. Now again, that one was a little tricky because there was no line where it was an easy starting place, right? Because there's multiple ways to make all of these things come out the way we need them to come out. So why did I pick true false for BU? Well, because it made the conclusion false, that's what I wanted to do, but also made two of the premises come out true. So it gives me a lot of what I need. It gives me a false conclusion, two true premises, actually three true premises, right? If one's true, one's false. So that's the idea, is if there is no definite letter to pick, like here you have to make H false in order for not H to come out true. If there's no definite letters or values to pick for letters, then you have to do what's called sort of trial and error, right? So you try filling those in, see if you can make it work. Now the thing is, if that didn't work, we could have gone back and tried something else, right? In the brief truth table method, that's one of the disadvantages of it, is that it might not give you a solid answer the first time through. You might have to try multiple combinations. All right, so be warned. But generally, if there's a place to start where it has to be a certain value, like B or I, to make that false, has to be B false and I false, that's where you should start. All right. Otherwise, you might have to do a bit of trial and error.